What's the probability of you drawing one gumdrop and finding out that that gumdrop is a lemon gumdrop?
320.
Does that mean that every bag or box of gumdrops, the probability of getting a lemon is going to be 3 out of 20?
No.
But if I took a whole bunch of boxes and dumped them together, would that be getting closer to the actual probability?
Yeah.
See, so I can't make that prediction off of one fish. I can't make that prediction off of one bag or one box. But if I do enough of the experiments, I can get an idea. But see here, this is a sample that's leading you to be able to talk about a probability of the problem. I don't know how many gumdrops that they made over the course of the last year at that gumdrop factory or something like that. So now they want this probability. Notice they're telling you that you're going to type in an integer or you're going to type in a fraction. So why do they say an integer? Because the probability could be 0 and the probability could be 1. But more than likely it's going to be something that's sandwiched between 0 and 1. And if that's the case, they want a fraction. So you've got 4 out of the 20 gumdrops, 3 out of the 20 gumdrops that are lemons. Does 3 over 20 reduce? But if it were 4 over 20, you'd be expected to reduce that to a simple fraction. Okay, you're now saying, oh shit, I'm not good at fractions, okay? Guess what? Your calculator is. Because if you have a fractional response to the problem, such as, say, I have 4 out of 20, and you type math 1 onto the end of that, it will reduce your fraction to lowest terms for you. The newer 84 models will actually build it as a fraction where it looks like a numerator-denominator. Everything else writes it as the slash version of a fraction. Now, I've just taken away your I don't do fractions excuse for missing problems. Because the calculator will do it for you. Okay? All you got to do is be able to count. That the calculator will not do for you. That's something that you have to be able to do. Okay, so back to the notes again. So there's our probability. So let's start talking about examples. These are typical types of problems that will be written in words or they might be written in symbols. So in this particular case, they're asking us to determine the probability of drawing a king. We need to know two things. We need to know the number of kings, because the numerator always controls the count of what satisfies our needs compared to the total number. All probabilities are a ratio of a part to a whole. So you still have to be able to count. But this is only one event, so my counting should be pretty simple. How many kings are there? And how many total cards are there? And if you write 4 over 52, it will say, although your answer is equivalent to the correct answer, you ain't done yet, because you didn't reduce it to lowest terms. So this would be expected to be a 1 out of 13. And if they wanted a decimal, then they would tell you how many decimal places to keep. Sometimes they'll ask for a fraction, sometimes they'll ask for a decimal. Determine the probability that that card being drawn is either a king or it's a diamond. So how many kings are there?
4.
How many diamonds are there? And because you have an or statement, do you also have to be worried about both? Are there any of those kings that you've already counted that are also a diamond? Or any of those diamonds you've also already counted that are also a king? Doesn't make a difference which one you start with, right? So is there one card that has been in both sets? So you are still going to have to use that overlap concept of an or statement when you're looking at a single event in the problem. And how many total? 52 cards. So now whether you do the arithmetic yourself or not doesn't make a difference, but if you put 17 over 52, it is surely going to be wrong because you double counted and said there are 2 king of diamonds in that deck, and that ain't fair. So now I'm going to end up having 16 out of 52 which can reduce down to a better looking fraction, which would be 4/13, or it could go down to a decimal if we needed to. All of those are things that the calculator can do for us. Less places for us to be able to get partial credit simply because the calculator is doing so much of the work for us. Where we might get partial credit is showing a setup step involved in the problem. Okay? Determine the probability of drawing the ace of spades and the jack of spades in two separate draws if the first card is not replaced before the second card is drawn. Do you have a simple event or do you have a compound event? Because how many cards do you have to draw? Two. Card number 1, card number 2. Which means since you've got a compound event, you've got a multiplication problem. Do I care what order those cards came in?
No.
See, probability doesn't care about order. So that's one less thing you have to worry about. But now the lines we draw for the bars, the fill in the blanks exercises, now become what satisfies my needs and what might have happened whether I liked it or not. So how many jack or ace of spades are there? 1 out of the 52 cards is the ace of spades. And my other need is the jack of spades. How many jack of spades are there?
1.
Only 1 out of how many cards?
52. Oh, 51.
Now they could have said, what's the probability of you drawing 2 cards in succession that are the ace and the jack if the cards are replaced? That would now make 52 for both denominators because you've reloaded the deck of cards by putting that card back in. But if these are being dealt to me in my hand and I'm playing blackjack, I ain't giving you that card back. It's still going to be in my hand. Okay? So this then, you're still going to see decrease of denominators in the problem when something is not able to be reused. And this poses an interesting problem. Because now when we come to the calculator and we tell the calculator that I want 1 divided by 52 to be multiplied by 1 divided by 51, the calculator says, there you go. And you go, yeah, exactly that. Gee, what the hell? The calculator is programmed, you can't change the programming, to never present a decimal value that has more than 2 leading zeros. So what you're going to see is the calculator giving you a version of the problem that's called scientific notation. 3.846, 153846 e negative 4. Meaning 3.846, 153846 times 10 to the negative 4th, which means that you are expected to move the decimal points 4 places to the left. Which means now, then we got a bunch of other crap back there, there's 1 place of movement. Now there's a 2nd place of movement, which means you've had to annex another 0. Which now means there's a 3rd place of movement, you've annexed another 0. And finally you get to the end where you have your last 0. You've had to annex 3 zeros to be able to get that number as a regular number.
I put 50, so it's not right. That's cool.
Oh, so I did 52 and 50. I made an arithmetic mistake, which is a good idea about why we make sure we show something on the paper, because if that were the arithmetic mistake you made, you complied with the content of drawing 2 cards, but because you typoed something, it's going to be all wrong. So, my bad, but at least I got that part of it right. Okay, so this should have been a 77073965. And that means I got the same key values that are sitting here. So I got 77073639. 0.065. Which means down here I got 7707, a bunch of other things that are back there. So it doesn't change the fact that now I've got a whole bunch of string of decimals out there. The author likes either 3 decimal places a lot or 4 decimal places. If he said 3 decimal places, wouldn't this be where we would be centering our concentration? And 3 is less than 5, so we would drop all the decimal places, right? Which would lead you to have a 0, 0, 0. Which would imply to a reader that the probability of that event happening is a 0. It can't happen. Could it happen?
Yes.
That you get both the ace and the jack of spades? Absolutely. So this is a problem where they will probably end up saying, wait a second, we want 6 decimal places. So now doesn't that become the focus decimal place? So there's 1, 2, 3 up here. There's 1, 2, 3 right there, 4, 5, 6. So now we're making a decision off of the 0. So this value would be written as 00377. That's what we would enter in with 6 decimal places. What if they say that they want the answer as a fraction? Well, theoretically, I can just tack on the math 1 to the end of my operation, or the end of the thing that got displayed, and it should turn it back into a fraction for me. But the calculator ain't that smart. It is that smart, it just doesn't have enough memory to be able to produce the answer. So there are some problems you're going to have to be able to do yourself by hand. Oh my God, but I hate fractions, but don't you know how to multiply fractions together? Don't you multiply the numerators together? And last time I checked, 1 times 1 is 1. And the last time I checked, won't my calculator do 52 times 51 for me? So if I have to do this problem in pieces, then I have to do this problem in pieces. If they want a fraction answer, your calculator may not give it to you because it can't turn the decimal back into a fraction. You got to suck it up and do it yourself. But still, you got a calculator that's doing the multiplication problems for you, so I'm not too concerned about that. And I'm not going to, those crocodile tears that are coming out of your eyes are not going to sway me. But I can't do that. Yes, you can. And this is nothing more than filling in blanks. An experiment consists of drawing 1 card from a standard 52 card deck. Let F be the event that the card drawn is a face card.